All right. So continuing on through chapter 1 here. So looking back at the last one, so write an equation of a line passing through with negative 3, 1, and is parallel to a line of the equation y equals 2x plus 1. So, starting with, this is going to be our slope. Whatever's in front of x is the slope of the equation. So for parallel, we want to have the same slope. So our m in this case is going to be 2. And then we're going to use this point. So y minus y of our point equals the slope to x minus x of our point, which makes it plus 3. And then we'll solve for y. So distribute the 2 in. Y minus 1 would equal 2x plus 6. And then add the 1 to cancel. And so y would equal 2x plus 7. Okay. Now, we've kind of talked about this before. But as far as base graphs go, these here are your 7 basic graphs that you're going to see more than anything. So, and really your first 2 are together. So there's 6 that you're going to see here more than anything. But a constant function is just one that's it's horizontal. There's no up or down. Identity function is going to be y equals x. So it's going to be going through at a slope. Now, this is a linear function. So the y equals 2x plus 1 would have some sort of a line for the graph. Absolute value will always be a v. A quadratic is a parabola. Square root is a sideways parabola, but it's only half of it. Otherwise, it's not a function. Cubic function looks kind of like a weird S. And then cubic root function is just that turned sideways. And there we go. Now, what can we do with these graphs? Well, each one can have a way to shift or manipulate, change up those graphs. So, if it's to the outside of the function, if we're adding or subtracting, it's going to raise or lower it by that amount. Now, I'm going to go through, I'm going to do some examples of these here in a little bit. So, stick with me here. Horizontal is if it's on the inside of the function, add or subtracted, but does the opposite. So if it's plus c, you're actually going to go left that amount of units. If it's minus, you're going to go right that amount of units. If it's negative on the outside, it's going to flip it across the x-axis. So if it was up, it's going to flip down. If it was down, it's going to flip up. If it's on the inside, it reflects across the y. So if it was right, it'll go left. If it was left, it'll go right. Now, if you times on the outside, that will stretch it. So if you're above 1 anyways, it'll stretch it. It'll make it taller. If we're between 0 and 1, that'll shrink it. It'll make it smaller. Now, if we're on the inside, it's going to do the opposite effect. So if we're greater than 1, it's going to make it skinnier. If it's between 0 and 1, it's actually going to make it wider if it's on the inside. So let's do some examples. So dealing with f of x equals x squared here. So first thing I'm going to graph is I'm going to graph that x squared formula. So it's going to go something like this. So 0, 1, 1, 4, 3, 9. Except it should be a straighter line. And then it'll be doing the same thing on the other side. It'll look something like that. Well, how will this one change it? Well, first off, this here is going to make it go down 1. This being a plus 3, that's on the inside of the function. That's going to make it go left 3. And this 2 on the outside means it's going to be twice as tall. So, if I'm at 0, 0 here, I'm going to go left 3 and down 1. So 1, 2, 3, down 1. Here's where my new center is going to be at. If I'm at 1 here, I would be twice as tall. So I'd be at 2, and then I'd go 1, 2, 3, down 1. and be right here at, well, at 2 should be at -1. So then now there's two different ways we could do this. Is I can shift them like that, or we can do an XY chart. And so I'm going to pick then one more to the left, so -1. Actually go to the right as well, so -4 and -5. So if I put -1 in here, -1 plus 3 would be 2, 2 squared would be 4, 4 times 2 is 8, 8 minus 1 would be 7. Now, if I'm at -4, I should get something similar to that last one here. -4 and 3 is -1. -1 squared is 1. 1 times 2 is 2. 2 minus 1 would be 1. -5 should be like the last one here. So -5 and 3 would make 2, which is squared is 4. 4 times 2 is 8. Minus 1 would be 7. So I can go 1 up to 7, put a dot. And go -4 up to 1, put a dot, and -5 and go up to 7, put a dot. So for 1 we're shifted from the origin, we're left and down, and then we're skinnier than what that one is because we're going to be twice as tall. Now, don't worry about this graph on your notes. That was just showing, I should get rid of it, but I put it all into one instead. You could do like, oh, here's the shift, and then here's where it's twice as tall. Just a way to kind of break up what's all going on here. But this is stuff you should look at and go, okay, so this is what this means, this is what this means, this is what this means, this is how my graph is going to change. All right. So again, working with x squared. So x squared normally goes with 0, 0, 1, 1, and then 2, 4, and then 3, 9. And we're symmetric on both sides, so we can put those graphs in and we can draw those up. So this is the base graph we're going to start with. So again, what are we doing? Well, this is too tall. This one here now, -1 means right 1. And +3 means up 3. So from the center, I'm going to go right 1 and then up 3. And that's going to be my new center. Now, I'm just going to go to the XY chart here. So, easiest way to do this now is instead of doing all the shifts and transformations with this, we know this is our center, pick 2 to the right, 2 to the left. So if I do 2 and 3, the other way I would go 0 and -1. So then you can come back here and put it into that equation. 2 minus 1 would be 1, 1 squared is 1, 1 times 2 is 2, 2 plus 2, or 2 plus 3 gives us 5. 3 in there, 3 minus 1 is 2. 2 squared, 4, 8, 11. Now, since it is symmetrical going the other way, you should get the same thing, but I'll check and make sure. So 0. 0 minus 1 is -1. -1 squared is 1. 1 times 2 is 2. Plus 3 gives us 5, which would also give us 11 on our next one, doing that same idea. So go ahead and graph in those. So 2, I would be at 5. 3, I would be at 5, or 0, I'd be at 5. 3, I would be at 11, it's just off the screen, and it would be that same spot at -1. So it should be something like that. So again, we're shifted and we're skinnier, so it's been transformed. And that's it. That is it for this lesson. Let me know if you have any questions, comments, concerns. Let me know if need any help with anything. Remember, you can always pan me. You can send me a message on Google Classroom. You can email me, Remember, you can always pause these if you need more time to write something down, or you can rewind them, watch them again if you need to, if you missed something. Don't be afraid to do that. Take advantage of it being a video. Otherwise, until next time, we'll talk to you later.